All right, so we're down to 11 days until we're starting up those EOGs. All right, so today, like I said, we're going to go in detail on each of these topics a little bit. We're going to do the laws of exponents or the exponent rules. So those of y'all that got the study guide, this is in there. Just to go over real quick. When we multiply with exponents, what you're doing is when you multiply with exponents, we're looking for the ones that have the same base, so the same big number. So right here we got 2 times 2 to the second power times 2 to the third power. You add the exponents. You keep the base. We don't multiply the bases, you keep the base. So 2 to the second times 2 to the third becomes 2 to the fifth. So when you multiply, add the exponents, keep the base. When you're dividing, still keep the same base. All of this we're keeping the same base. So when we follow our exponent rules, the big number, the base, stays the same. We subtract our exponents. So if I got 7 to the 6th power divided by 7 to the 4th power, that becomes 7 to the 2nd power, 7 squared. If I have the exponent of an exponent, power to a power they call it, that is where we multiply our exponents. So I'll write it a little bigger so we can see it better. We've got 2 squared and all that to the 3rd power. That is where we multiply. So exponent of exponent, we multiply our exponents. So that becomes 2 to the 6th power. We don't do this one as much, but if they have multiplication inside the parentheses, like 2 bases in there, that exponent goes to both of the numbers inside the parentheses. You see that a little bit more with Math 1, not as much with the 8th grade math. If we have negative exponents, what happens with a negative exponent? You flip it. So if there's a negative exponent on a denominator, it flips it to the top. If there's a negative exponent where it's on top, it flips it to the bottom. And once you flip it, it becomes positive. So the example here, we got 7 negative power. It flips it over. It becomes 1 over 7 squared. If I had 1 over 7, the negative squared, or 7 to the negative 2, it becomes 7 squared with the 7 squared on top. It'd be over 1. I don't need to write the over 1 though. Everybody follow with what I'm saying? So negatives flip it. If it was on the bottom, it goes to the top. If it's on top, it goes to the bottom. And then anything to the 0 power is 1. Anything with an exponent of 0 is 1. Okay? So if I have 1 to the 0 power, that's 1. If I have 8 to the 0 power, that's 1. If I have 387 billion to the 0 power, that's 1. Okay? All right, so if we look at these here, I know these maybe are a little tiny. We're looking for which one's a true statement. So A here, I got multiplication. When I multiply, what do I do with my exponents? Add. So I've got 19 to the 21st power and 19 to the 3rd power. I should have 24, right? All right, so that's got 19 to the 63rd power. So that one's not true. All right, exponent of an exponent, what should I do? Multiply. So I've got 24 to the 8th power and all that to the 5th power. So 8 times 5 is 40, and that's got 24 to the 40th. That one's true. If we looked at the other one, that's multiplying. So I would add my exponents. 1 plus 0 is 1. That one, didn't add them. When I divide, what do I do with my exponents? Subtract. 40 minus 20 is 20. They divided the exponents. That's not what we want to do. Okay? So, just kind of looking at some of these. This one just has letters. For the most part, 8th grade math, you'll see more numbers than letters. To me, I think actually the letters are easier, but you'll see that more next year. All right, so what do I do with negative exponent? Flip it. So I've got d to the negative 5 on top, so I'm going to put that on the bottom. I'm going to use capital letters just because my handwriting's bad, okay? So d to the 5, I flip it to the bottom. I got d to the 3 on top. I'm going to go ahead and do this one too. Exponent to an exponent, what do we do? Multiply. So d to the 4th to the 3rd power. 12. So we got d to the 12th. Okay? Everybody okay with that? All right, so I got d to the 3rd on top. We're going to leave that right now. I got multiplication on top with those. 5 plus 12. All right, so I got d to the 3rd on the top, d to the 17th on the bottom. All right, now here's where I actually think it gets kind of easy. Where are there more? On the bottom. How many more? 14. So we still want for our answer there to be more on the bottom. And there's 14 more on the bottom. So our answer should have 14 more on the bottom. That makes it A. Everybody kind of follow on how we work through that? So we flipped the negative, right? I did exponent of an exponent. And then it's just a matter of we combined them with the multiplication by adding. And once we have some on the top, some on the bottom, we're just looking to see where there's more of them, okay? It's subtracting. 3 minus 17 is negative 14, because that was division, we subtract. If it's negative 14, I flip it, put it to the bottom, but I think it's easier just look at it where there's more, okay? So let's look at another one. All right, so I got f to the 9th times f to the 3rd on top, f to the 4th on the bottom. So if I've got f to the 9th times f to the 3rd on top, how many I got on top? 12. I got 4 on the bottom then. So if I got 12 on top, 4 on the bottom, how many I got, or where do I have more? Top, how many more? 8. So what's my answer? C. Like I said, a little easier, I think, with the letters. So it's always weird to me that they put the letters with Math 1 and the numbers with 8th grade math. Yeah. All right, so this one gets a little trickier. We have to figure out what that x equals. All right, so on the left side here, exponent by exponent, I multiply. So 10 times 3 is 30. I got 15 on the bottom. Subtraction, right? What's 30 minus 15? 15. So on the left side, I got 15 b's, or b to the 15th power. Everybody clear on that? That means we need b to the 15th power on the right side. If I subtract, I got 18 on top. I subtract 8. I got 10. How many more I need? 5. So x equals 5. Yeah. I need 5 more. We got to make the sides match. All right, I'm going to rewrite this one so it's a little bigger so you can see it better, okay? I got a to the 2nd, b to the 7th, all that squared, equals a to the 4th, b to the x. We got to figure out what x equals. All right, who thinks they can tell me what x equals? $14. All right, exponent of exponent, we would multiply, right? 2 times 2 made 4 for the A. 7 times 2, we got to make 14 for the B, right? We're looking for which one of these has the greatest value. All right, so do we have to multiply all these out and figure out the numbers? Not really. We have to figure out which one has the highest exponent. All of them have 3 as the base, right? So if I've got 3 squared to the 3rd power, what's my exponent on that one? 6, yeah. So I'd have 3 to the 6th power. 3 to the negative 2nd to the 3rd power. What would my exponent be there? 3 to the negative 6. Or if I went and flipped it, I'd have 3 to the 6 on the bottom, 1 on top, right? Either one, same idea. 3 to the 2nd times 3 to the 3rd. What would that be? 3 to the 5th. When we multiply, we add our exponents. Which one? Yeah, D would be 3 to the 1st power. Or what's anything to the 1st power? Anything to the 1st power is just that number. All right, so which one's highest? A, yeah. Now, if we had to actually do the math, you would have to do 3 times 3 times 3 times 3 times 3 times 3 to figure out what the actual number was. Is that impossible? No. But here, hey, look, we're multiplying 6 threes, right? 3 times 3 is 9. 9 times 9 is 81. Then you would just do 81 times another 9. Makes it a little easier doing it in chunks, okay?